My name is Ashutosh Mishra and today I am going to teach you the topic complex number. Okay, so let's start with the complex number. Okay, the topic name is complex number. Complex number. Okay, before starting with the complex number, let's have a look on various types of number. Okay, as we know there are various types of number. The first one is the natural number, and the second one is whole number, and the third one is integers. Okay, and the fourth one is real. Okay, the fifth one is rational number, and the sixth one is irrational number. Okay, I assume that you people have heard about this. Okay, that is natural number, whole number, and integers number. Okay, so but still I'm going to tell you what is the integers, what is a whole number, what is a natural number, what is a real, and all that. So the natural number, which is starting from 1, 2, 3 up to infinity, and the whole number, which is starting from 0, 1, 2, 3 up to infinity. Okay, and the integers are nothing but negative, positive, and that means minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3 up to infinity. Okay, minus infinity to plus infinity is nothing but integers. Okay, and the real number is nothing but the number which is natural number, whole number, and integers are nothing but the real number. Okay, real number are every numbers are real number. Okay, minus 3, minus 2, minus 1, 0, 1, 2, 3, even 2 by 5, 4 by 5, these are the rational number. Root 3, root 5, root 2, these are the irrational number. So which comes under the real number. Okay, and what is a rational number? Which is represented by a by b, that is 5 by 2, 5 by 6, 3 by 2. And then what is irrational number? The number which is real number but not rational number. It means it is root 5, root 6, root 3. These are the irrational number. Okay, what is complex number? Right, the number which is represented by a plus ib. The number, I repeat, the number which is represented by a plus ib, where a is real part of complex number, and b is the imaginary part of the complex number. Imaginary part of the complex number, where I is nothing but root of minus 1. Okay, we can also say where a and b greater than 0, and these are the real numbers. What is a and b? These are the real numbers. It can be minus 1, it can be 1, it can be 5, it can be minus 5, it can be everything, even root 3, 3 by 2, these everything, you know. So where I is equal to root of minus 1, then I square will be minus 1, then I cube will be minus I, then I raised to 4 will be 1. Okay, as we increase the power, then you will get the number accordingly. Like if you have I raised to 5, then you can write I raised to 2, I raised to 3. What is I raised to 2? Is nothing but minus 1. I raised to 3 is minus I. You can write plus I. I raised to 5 is nothing but plus I. Okay, so there are one topic, that is how to get a conjugate of the complex number. If the complex I again repeat, the complex number which is represented by a plus ib, we can write z equal to a plus ib. Okay, if we want to take the conjugate, of the complex number, then the conjugate will be represented by z bar. Okay, conjugate will be represented by z bar. Then the conjugate will be a minus ib. Sorry, a minus ib. Suppose I have a number 3 plus 4i, and if I want to take the conjugate of this, then the conjugate will be 3 minus 4i. Only the imaginary term get changed, not the real part. Okay, not the real part. Okay, only imaginary term get changed. Suppose 7 plus root 6i. Then if I take the conjugate of this, then it will be 7 minus root 6i. Okay, and the next part will be the properties of the complex number. As we know, there are various properties, not various, there are 4 properties of the complex number. The first one is addition properties, and the second one is subtraction properties, and the third one is multiplication, and the fourth one is division. Okay, so I'm not gonna write that properties. I'm just gonna proof. I'm just gonna give a proof. Okay, the first one is addition of two complex number. Okay, suppose I have a two complex numbers, z1 equal to a1 plus ib1. As I said, the complex number can be represented by a plus ib. So z1 equal to a1 plus ib1. Okay, and the second complex number is z2 is equal to a2 plus ib2. Okay, and if we want to add these two complex number, that is z1 plus z2, it will be a1 plus ib1 plus a2 plus ib2. Then the real term get added, a1 plus a2 plus ib1 plus b2. Again, this is the real part and this is the imaginary part. Okay, the second property is subtraction of the complex number. Subtraction of the complex number. So z1 minus z2 will be a1 plus ib1 minus a2 minus ib2. That is minus, then z2 is nothing but a2 plus ib2. If we multiply minus, then it will be minus a2 minus ib2, right? Then here a1 minus a2 and plus ib1 minus b2. Again, it is a real part and it is the imaginary part. The third one is multiplication and the fourth one is division, right? Multiplication and division. If we multiply two complex number, that is z1 into z2. Okay, z1 into z2, then it will be a1 plus ib1 bracket, another bracket, a2 plus ib2. Then multiply a1 into a2, right? Then I a1 b2 plus I a2 b1. Then ib1 minus ib2, ib1 into ib2 is nothing but, minus I into I, it will be minus 1. Then it will be b1 b2. Okay, then just take the real part of the complex number, that is a1 a2 minus b1 b2. This is the real part of the complex number, these two. Okay, and the imaginary part is I take a I common. Okay, then it will be a1 b2 plus a2. This is the multiplication of two complex number, right? So the next one is division of two complex numbers. Okay, division of two complex number. It can be represented by z1, like simple division. Okay, simple division, z1 divided by z2. Okay, what is z1? a1 plus ib1, a2 plus ib2. So from here we cannot go further. To go further, we have to take the conjugate of the denominator. Okay, what is the denominator? Denominator is a2 plus ib2. Okay, so the conjugate of a2 plus ib2 is equal to a2 minus ib2. So multiply by conjugate on numerator and denominator, a2 minus ib2, a2 minus ib2, right? So here a1 plus ib1, a2 minus ib2, right? Then here it will be a2 square plus b2 square. You just multiply these two numbers, a2 plus ib2, a2 minus ib2, then you will be get a2 square plus ib2 square. Okay, now again multiply by this, then it will be a1 a2 minus I a1 b2 plus I a2 b1, again ib1 minus ib2, then if ib1 into ib2, then it will be minus b1 b2, but here again minus, then it will be plus b1 into b2. Okay, a2 per square, b2 per square. Okay, now take the real part, that is this a1 a2 plus b1. Now imaginary term I a2 b1 minus a1 b2, this one minus a1 b2, then whole divided by a2 square plus b2 square. If you want to take the real part of the conjugate complex number and imaginary part of the complex number, then divide this, that is a1 a2 plus b1 b2 a to the whole square plus b to the whole square plus I a2 b1 minus a1 b2 divided by a2 square plus b2 square. This is the real part and this is the imaginary. Okay.